Project, just as a reminder, is the WASH AI data discovery. So we focused on essentially developing a data pipeline for water and sanitation data that came from various different sources, APIs, data sets. And so we didn't have time to cover everything, but we will go through a few little things that we were able to figure out and learn in this project. And showcase some of what we achieved. So a reminder of what we're looking for and what we did was essentially accessing large data sets within the water and sanitation sector, often API endpoints, and finding a way to extract the data that was mostly relevant to be able to store it so that we could use large language models to pull the right schema of the data set that was the most relevant to a question that would come up in plain English language. For example, here, how does sanitation coverage in Muhanga, Rwanda compare to Mbala, Zambia? So based off of a plain English language, we wanted to use a language model to generate a SQL query that would not only pull from the right sub-data set, but also actually get the data itself. So to do that, we had to figure out these data sets, extract only the relevant data, extract the schema, so that, because some of these had many, many columns, and we couldn't dump all of those columns into the context window for our language model. So we had to come up with ways to do that. So that's the overall view. A lot of learning in this initiative, and that was the point. This was all new. This is very new. This hasn't been done really. I haven't seen examples of this being done yet using language models to this extent. So that's the intro, and we'll dive into a short explanation from Kelly, who worked with Negar on one of the data sets. And just to speak to some of the data sets that we covered, we couldn't cover all of them, but the first one was DHS, which is the Data Health Survey, which is a very large data set around health indicators. So there was over 200 indicators, no, there's actually like 500, I think, at least, of which many, many were water and sanitation related. So the two of them worked on that, so they'll be presenting that next.
Hello, everyone. My name is Kelly Yuan. I'm from WASH team. Basically, I've created two pieces of notebooks. One is for DHS data exploration. Another one is for large language model data query. So in the first notebook, my team member, Naga, and I, with the help of Olivier, have created two functions to call API to pull in DHS metadata and DHS all data sets. And all those data are saved as a CSV file. In the second notebook, I've tried out requesting two large language models to create SQL queries to answer user questions. For example, the user question is, what is the population with improved water source in Ghana? And I tried to fire a Llama v3 70B and GPT 3.5 Turbo, and the results shows that by using the send important system message, obviously GPT performs much better results than Llama 70B.
Next, I wanted to present overall what we achieved with pulling these data from these data sets. So the first thing is actually the data database, the one that we referred to in this data store, basically, is what we're referring to here. So essentially, the data store looks like this. There is I'm going to push this away. There is a metadata table that stores really per row each indicator. An indicator could be a field and a value. And it's got a title, it's got a data type, and it really just refers to the information about the types of data that we can pull. And then the data set, there is one row per data set in this table, which it has a full schema that is written in JSON-B, and I can show you what that looks like. And then also has a flag to say, has it got indicators? And then it will then connect to the metadata so that it might, like for example, the DHS table has over 200 indicators. So we want to have one of those indicators per row in the metadata table. So we only pull those indicators that are relevant. And by indicator, really think of it as a column. For example, people with a safe, with an improved water point would be one indicator, and then there'd be a value, maybe 50%, right? And then there'll be other information. So that's just the metadata around each indicator. And this can be agnostic to any kind of data set. For example, the JMP data has its own indicators, and they can all be inserted here as well. Now, where the actual data store is each within its table. So right now we have this one table, which is just for DHS, and we'll have, for any large data set, they'll have their own table, which is generated. So again, here it will have simply the indicator and the value. So it will be pulling this. This is actually connected here between the metadata. So the indicator ID, the value for that indicator, and then any extra metadata that is really unique to this data store. So in this case, the survey year. So when was this indicator gathered? And then the country name, like in the example earlier of Ghana, for example. So that would be this table, which would have one row per indicator, and then the actual value is there as well. And we have the metadata about that indicator in this metadata table here. So going back to how things work, I'm going to walk you through the specifications. So these tables I've shown you. So here's an example of in Markdown what the table would look like. So that's the indicator. This is the improved water source, 98% in Albania, and the survey year is 2017 there. The way we actually generate the schema that we store about this table is we use a language model. So here's the prompt that we inject with a language model, and we simply say, you are an expert in data analysis. From the simple sample data set, provide a JSON schema and include type and description. So we actually dump some of the initial data. So we just took the, the DF head, for those who knows how Panda works, data frame, first 10 rows, take the data, we dump it into the language model here. This gets replaced by this value here. And then, sorry, actually goes here. That actually goes here. The dataset information is more just a narrative around this dataset, so the description of the dataset, but the actual data goes here. So we're giving the language model enough information to compose something. And here, even just using a very simple small model, a Llama 8 billion parameter model, it will generate for us, because of our prompt, we asked it to generate JSON. It'll generate this really nice, basically schema, explaining that it's got something called data ID, and it's an integer, and it's the unique integer, the year, so the year, the survey year, and it provides a description. And the reason we're doing this is because later on, when we want to say, we want to query data, we want to know, we need to have an English description, because we're going to use the language model to pick which row. And so this principle can be applied to other smaller data sets. For example, in a PDF, you've got a table like this. We can also get it to extract the metadata. So it shows number of responding countries, an English explanation to it, total reported expenditure, again, and this I'm referring to this table here. And so it generates for us a schema. So we're able to replicate this across any kind of data set, generating a schema and then storing it in our dataset table here. And for those that has a lot of indicators in the table there. So in this last section, we're briefly going to look at how to tackle this right side, the data exploration. So given an English question, we're going to transform that into pulling the right schemas and the right data sets that are relevant to this question, and then creating the right SQL query that is aligned with the data sets that have been pulled. So I'm going to use a practical example for that. So the first thing we need to do, let's say the English question was, through the interface, was what is the proportion of population with access to improved water source in Ghana? Plain English question. So the thing we're going to do is we're going to query our two tables that I presented briefly, the metadata, and we're going to join the dataset table. So the metadata, remember, is the table that has the list of indicators. So to give you an example of what could be in this metadata table, it will have a long list of indicators that come from various data sets. In this case, some from DHS WASH, some from the JMP. So this could be extremely large table, standardized in that it's got an indicator, protected people who use a protected dog well, etc. But it won't have the data itself, just the metadata about these indicators. So we're going to run this query, let me break it down for you first, because what we want to do is we want to identify which indicators are relevant to this English query. So to do that in Postgres, you can use what's called a TS vector comparison and then rank them. So we're actually taking the description of that indicator and we're taking this user question. And so this gets replaced with what is the proportion? So this actual string, English question. And we're going to compare that description of the indicator to the question. And then we're going to rank them, and then we're going to order by rank. So the higher ranked ones will be the closest indicators that match that user question. So let's run it. And I've run it there already. And so you can see I replaced it with a question. And now we can see that it found, and I said limit 5, taking me the top 5 indicators. So it found in the JMP data set, it found these indicators, which seems to be correct. Improved drinking water sources located on premises. So there's actually a variety of improved drinking water sources. So now we have not only a few of them, but we have their indicators IDs. So we will grab this data and we will put it into now our language model so that it can create the SQL query for us. So we tell it that it's an expert in SQL queries. We will dump the schema of the table that we queried from here. So we know which data set to pull it. So we'll grab the schema from that. And in this example, if I look at my tables, my data set table, it will take the, in this case, because it found indicators from the JMP table, we're going to be grabbing this explanation, which I explained earlier. So this will tell it what that table data set looks like. We will dump the 5 top indicators that it found in there, and then we will repeat the question, which was about the people in Ghana with safe drinking water. To call example and pulling it all together, we've now formulated the prompt to generate the SQL query. So this is the system part of the prompt, which is just saying that your role is to generate a SQL query. We want to make sure it aligns with an actual data set that exists, so it's not making up table names or making up column names. So we've dumped the schema, the one that we just queried, around each of the relevant indicators. So we remember we got a rank, we got the top 5. So it found these 5 indicators, and we've just switched it from a typical, a tabular view to a JSON view. It doesn't really matter, but essentially we're saying here's the indicator ID. This is the table name in which this indicator exists. And we've done that for each of those indicators. And so we've dumped the query there. Again, only the most relevant ones. And this speaks to, we can't dump all of the indicators of every single data set, because this would just be too big for the language model to absorb. So we've only given it what's most relevant. And then we've repeated a question, very important, the proportional population, so that it can generate the SQL. So here it is. We're using, in this case, GPT-4o programmatically. This is the same system prompt as it was there shown. And then this is just the data that I've put here as the user message. And if we run it, it will generate here the assistant response. It generated a SQL string asking for the year, the value from dataset JMP, where country equals Ghana. It knew it had country field available, and the indicator ID of this one. So it picked only one of them, which if I actually look for it, it's the, where would it be? Up there somewhere. This is the one. Proportional population using, yep, that's probably the right one to choose as, and notice it's not the first one I gave it, it's the second one, because the actual English query was, what is the proportion with access to improved water source? So not on premise or anything. So it actually picked the right one of those 5 top indicators, and it gave me a SQL query that will work as we apply it to this table in our system. And it knows that this indicator exists within that table because of our schema. So that's it, all the pieces together. And the idea is that this fully scales, and we're able to just continue adding data sets, and that we can be using plain English language programmatically to query a data set and pick out rich indicators to pull from those data sets, and then we can run the query that the language model generated against the table, and we're able to get some of that data directly from any of the data sets. Thank you.